my dears. It's nice to meet you again. Hopefully you're doing well. Last time I have explained it, rules for solubility and precipitation. Today we have too many different questions to practice together, okay? So let's solve them. Stay with me. Here we have a series of questions. Question 1. Okay, however, it's question 9 because, you know, before this, I have solved 8 questions last time. That's why I'll start from the 9th question. Look, which of the following is correct? Which of the following is correct? So I'm looking for the correct answer. When solutions of potassium sulfate, what is potassium sulfate? K2SO4 and barium nitrate. This is barium nitrate, BaNO3 by 2. So if we combine the two salts that are mentioned here, which of the following will become the correct answer? First, as you can see here, we have the spectator ions, the precipitate, or the net ionic equation. That's why we need to do the 4 steps. First, write the double displacement, then the net ion, then the overall ionic equation, and cancel the spectator ions, the ions that do not appear in the net ionic equation. Lastly, we will specify the net ionic equation. Okay, but you know, to solve such a questions, I'm going to use the fast way. The fast way is very safe here. Look at it. Potassium sulfate, which is K2SO4, plus barium nitrate, BaNO3 by 2, to form BaSO4 plus KNO3. Okay, good. KNO3. And it must be balanced. Then their solubility, this is aqueous. As I say, this is the double displacement reactions. So, the both two reactants must be aqueous. Remember, for the double displacement reaction, both reactants must be aqueous. Then, here we have KNO3, it's aqueous, potassium-containing compounds or nitrate-containing compounds are always water-soluble. How about this? BaSO4. BaSO4, it's a solid compound, sulfates. Sulfates, according to the phrase of Serkay-Hadzi-Bapir, it's a member of Serkay-Hadzi-Bapir Ba. That's why it's insoluble. And then I say the soluble salt is the spectator ion. So the spectator ions are K and NO3. Here we have the spectator ions. And this one is the net ionic equation. How to write the net ionic equation? Hopefully you remember. We need to have a solid by the product side. This is BaSO4, which is a solid. By the reactant, we need to have the ions. Good. Plus SO4 negative 2, aqueous. Then let's see which of the following statements is correct. The spectator ions are NO3 and K. True. This is correct. The precipitate is BaSO4. Yes, this is also true. Net ionic equation is, okay, let's compare our net ionic equation with the question's net ionic equation. This is also true. The correct answer is D. Good. Next question. Look, find the spectator ions. The spectator ions when solutions of KCl and AgNO3 are combined. Okay, the spectator ions, it means the solid salt or the aqueous salt. Doesn't need to ask anything about this. It's really easy. The soluble salt, of course. KCl plus AgNO3 to form AgCl plus KNO3. Look at this. This is AQ, and this one AgCl. According to the rules, this is one of the exceptions. Chlorides, most of them are water soluble, but 3 of them are solid, like lead chloride in cold water, mercury monochloride, and then silver chloride. So this is a solid substance. How about KNO3 aqueous? Which one is the spectator ion? The spectator ion is the solids, aqueous salt, I mean. So the ions are here, K plus and NO3 negative. Which of the following which of the following ions are spectator? Let's see. K and NO3. This looks true still. Looks correct. KCl no. AgCl no. AgNO3 no. So the spectator ions are K and NO3. Another question. Remember, these are reserved questions. Be careful. These are reserved questions. Another question. Okay, look. Which of the following is correct when solutions of mercury chloride and potassium sulfide are combined? Look, mercury dichloride. Don't confuse with this one. Okay, I'll write both formulas and this one. Which one is more appropriate for this compound? Ag2Cl2 or AgCl2? Be careful. This is mercury mono. This is incorrect. This one is mercury dichloride. Okay, mercury 2 chloride. And potassium sulfide, which is K2S. So if we combine them, which of the following will be correct? Let's see. Which of the following is correct? So I'm looking for the correct answer again. Let's have the double displacement for the two compounds. K2S plus Ag2 or AgCl2 to form KCl plus AgS. Great. Now it's balanced. The physical states AQ. This one KCl. It's a water-soluble compound AgS. According to the rules of solubility and precipitation, sulfides we will predict their solubility according to the phrase of Cagnaster ammonium, if you remember. So Ag, it's a member of Cagnaster ammonium? No, that means it's a solid one. But Cagnaster ammonium with S, they will become water-soluble aqueous compounds. So this is S. Okay, let's see. The first one, K and Cl are the spectator ions. Yeah, true. Here we have the aqueous. The aqueous solid, the aqueous salt, I mean, will become the spectator ions. K and Cl are the spectator ions. True. This one? The precipitate is Ag2S. Let's see. Correct or incorrect? Look, is there something wrong with these two formulas? Yeah, are they the same? No. So this is incorrect. The precipitate is AgS, not Ag2S. How about this one? Net ionic equation is this. Okay, let's write the net ionic equation for this. We need to have a solid substance by the product side, the ions by the reactant side, and it must be balanced. So the correct answers are A and C. These are correct for the following combination, and this is incorrect. But the question said, which of the following is correct, appropriate? So A and C. And this is the correct answer. Another question. Look, which of the following is incorrect? This time incorrect. Be careful. Which of the following is wrong? Incorrect. Okay? For the combination of sodium carbonate, this is sodium carbonate and calcium chloride. Again, the lovely double displacement reaction. I write the reaction here. We have enough space. Na2CO3 plus CaCl2 to form CaCO3 plus NaCl. Okay? AQ. This is AQ because it contains Na. Na containing compounds are always water soluble. How about CaCO3? According to the rules of solubility and precipitation, look, there's no Cl. Leave the first rule. Neglect that one. It's not a sulfate. Even sulfide. So we go according to the last rule, which is rule number 4. There's no ions that are responsible for the aqueous compounds. So this one's supposed to be solid. This is solid. So the spectators are Na plus, Cl negative here. How about this? This one will become the net ionic equation just like this. Okay? Ca plus 2 and CO3 negative 2. AQ. This is the net ionic equation. By the way, the net ionic equation it's an opposite process to the dissociation reaction. So the reverse process of the dissociation reaction is called the net ionic equation. It's kind of like a formation reaction. Look at it. Which of the following is incorrect? Look, Na and Cl are the spectator ions. This is correct. Correct. No reaction occurs, it means no precipitate. No, there's a precipitate. This is incorrect. Okay? How about this? Net ionic equation is this. Look at it. Is this a net ionic equation? Look. The net ionic equation, yeah, this is correct also. So which one is incorrect? No precipitation occur. This is incorrect one. But if I say select the correct answer, then A and B are correct. In this case, the incorrect answer, so this is the appropriate answer, the suitable answer for this. B will become the correct answer for this question. Choose the wrong answer. Again, the incorrect answer. Okay? For the combination of copper chloride and ammonium phosphate, this is kind of challenging question because of the chemical formulas. Look at it. This is copper chloride, CuCl2 plus ammonium phosphate, NH4 by 3PO4. Let's have the double displacement for this. It will become Cu3PO4 by 2 plus NH4Cl. I'll leave the balance for you, okay? You don't need the balance. So you have to balance the reaction by yourself. These are AQ, this one, AQ, ammonium-containing compounds are always water-soluble. How about this? This is related to the last rule, the fourth rule, okay? The fourth one. There is no ion that is responsible for the soluble compound. So this is insoluble. This is S compound. Which of the following is a wrong statement? Look, incorrect statement. The spectators are Cu and PO4. No, the spectators are the soluble salt. These are the spectator ions, NH4 and Cl negative. So this is the wrong answer. This is incorrect. I will say this is wrong. It's better. Once you see something like select the incorrect answer or wrong answer, just write above the answers if it's wrong or correct. Then select the one according to the question. So this is wrong. How about this? No reaction, it means no precipitation. No, there's a precipitation. So this is wrong also. Net ionic equation is this. Let's have the net ionic equation for this solid compound. Bring the solid to the product side. Cu3PO4 by 2 to form, or that is produced from its ions, Cu plus 2 plus PO4 negative 3. AQ. It looks the correct answer. Hey. Please. What did I say about the net ionic equation? I said we need to have a solid compound for the product side and the ions for the reactant side. What else? Okay, is that needs to be balanced? Yeah, of course. Okay, look, this is imbalance. It must be balanced. Look, we have 3 coppers here with 1 copper here. It must be multiplied by 3. 2 phosphate ions here, but here we have 1 phosphate. Multiply this by 2. Then this is the correct net ionic equation. Is there any difference between them? Yeah, of course. However, the ions are correct. They have been placed at the right position. Same thing true for the compound. It has been located at the product side. But because this is not balanced, so this is incorrect. So which one is the wrong answer? All are wrong. So we'll select D. Question 40. Choose the wrong answer. We need the wrong answer. Wrong answer. Be careful. We need this answer. Wrong answer. For the combination of magnesium acetate and strontium chloride. What is the magnesium acetate? Magnesium acetate. This is magnesium acetate. CH3COO by 2Mg. Okay, how about strontium chloride? This is strontium chloride SR, Cl2. So let's have the double displacement between the two given substances, because we have two compounds. We have two compounds. We should write the double displacement CH3COO by 2Mg plus SrCl2 circle to form CH3COO by 2Sr plus MgCl2. Good. I'll leave the balancing for you. And then their physical states. This is AQ, acetate containing compounds are always soluble. Rule number 4. AQ. How about MgCl2? Okay. How was the rule of chlorides? Most of them are soluble, but 3 of them are insoluble, like HgCl, PbCl2, Hg2Cl2. But this is not a member of them. So this is AQ also. What? There's no solid compound. There is no reaction. Once you see no reaction, it means no precipitation reaction. Look, I'm looking for the wrong answer. No precipitation occur. No PPT occurs. Yeah, this is correct. How about this? Precipitate is MgCl2. No, there's no precipitate. So this is wrong. Precipitate is this one. This is also wrong. So select the wrong answers. Which of the following is the wrong answer? Both B and C are the wrong answers, which will become correct for this question. Okay? So that's how you select or how you answer the questions related to the select the wrong answer or incorrect answer. First, write the terms of correct or incorrect above the answers, then select the one according to the question. Okay? Let's keep going. Question 15. The number of the question is not important. Which of the following represents net ionic equation for the combination of look, net ionic equation. Let me do this, please. Net ionic equation for the combination of sodium carbonate and calcium chloride. Sodium carbonate, this is sodium carbonate, Na2CO3 plus, and calcium, this is sodium carbonate and calcium chloride, CaCl2. Let's have the double displacement, NaCl plus CaCO3. AQ on this one, AQ, this one is a solid substance. So which of the following represents the net ionic equation? Or which of the following is the best representation for the solid in the reaction between the two reactants that are mentioned here? So bring the solid substance here, which is CaCO3 for the product side, and then have the ions for the reactant side, which are Ca plus 2 and CO3 negative 2. AQ, and solid. So now which of the following is this? Okay? Everything is clear right now. This is incorrect. Look at this. تمشاك كفرية جواني بك تمشاك أورك حقيقي أول عامية سري ليبكيو سري ويكها. How about this one? No, this is incorrect. How about this? Are they the same? Yeah, they're the same. No reaction? No. So this is the net ionic equation for the reaction between the following lovely two reactants. Good. Another question. Okay, this is the same as previous question. I don't solve this. This one also. Let me show you the idea of, in this question we're combining 4 different questions. Look, which of the following double displacement reactions can produce precipitate? So we have to write, or we have to complete the double displacement for the following 4 reactions. Then will decide which of the following can produce a solid. Look at this. The products here are KBr plus NH4 by 2CO3. This is AQ, this is AQ. There's no precipitate here, no. This one, the products KCl plus Na2SO4. No, there's no precipitate because both are AQ. How about this one? Okay, the products are AGS, Ags plus NaNO3. AQ, how about this? Cagnasr, ammonium, sulfide compounds are aqueous, but this one, no, it's not a member of Cagnasr ammonium. So this is a solid substance. This is a solid substance. So still, this is the correct answer. How about this one? Let's have the double displacement reaction for this. It will become FeClO3 by 2 plus KNO3. Look, chlorate compounds are always soluble. This is soluble also. No, C is the correct answer. Okay? Okay. Another question. When solutions of BaCl2, look, however, in previous lesson I have explained this, but I will explain this from the first again because of its importance. Look, we have the two reactants of barium chloride and silver sulfate. Which of the following will be the precipitate? Okay, so let's have the double displacement for this again. BaCl2 plus Ag2SO4 to form BaSO4 plus AgCl. Look, AQ, this one, سكي حاجي بابير. Look, sulfates, this is solid. AgCl, it's a solid substance also. Oh, both products are solid. So all the ions are consumed in the production of the two solids here. Okay? Yalla. Which of the following is the solid substance or the precipitate that can be produced in this reaction? This is precipitate, but it's not alone. Wait. How about this? AgCl alone? No. BaSO4 and AgCl together? Yeah. This is the most correct answer. D, none of them? No. Okay? So C is the correct answer. About this, you know, I don't like to explain, to read, even to read the title of the question, really, okay? I don't like this. It's nothing. Okay? However, it's in my booklet, and I have a plan to remove this question. So you don't need this. You won't see this in Zhyar, never. Look at this. A solution of chloride. This is a nice question, really. This is a nice question. Look, a solution of chloride anion Cl. That means we have Cl. So it can produce a precipitate when it's added to a solution of. Look, we have 4 different solutions here. These are the 4 different solutions. This one also. 3, sorry, not 4. Now, I will add Cl to all of them. Cl here, Cl here also. So in which case the precipitate can be produced? In which case the precipitate will produce? Look, how to answer this. Or I can change the title, the form of the question. Cl can produce maximum attraction force with the following solutions. Okay? Because Cl is a negative ion, so we should bring the positive part of all solutions. The positive part here is Ca plus 2. The compound will become CaCl2. This is aqueous. Wrong. How about this? AgNO3. Look at it. Ag, it's a positive ion with Cl negative together. AgCl, it's a solid substance. Yeah, still this is a correct answer. Again, bring the cation here, okay, for the combination with Cl to form Fe fecal 2. This is AQ also, no. So Cl can produce with with the solution of what? AgNO3 or CnO3 by 2 or FeNO3 by 2. So this is the correct answer. Let's see if I have a more question. No. Okay. Thanks for God that we have finished the rules of precipitation and solubility. It's time for the ionization. What is the ionization or ionization? First, if you remember, I said electrolytes are classified into ionic compounds and molecular compounds. For the ionic compounds, as they dissolve in water, they dissociate. So we'll say there's a dissociation reaction, right? So ionic compounds are dissociate, right? Good. How about the molecular compounds? Are they dissociated or ionized? They ionize. So we'll say the ionization, okay? This is the main topic of today's lesson, the ionization. From now on, anytime, once you see which of the following ionizes in water, just say, Mr. I need the following classes. Look, either strong acid or weak acid. Weak acids. Aha, there's another class. Don't forget that one. Weak base. Weak bases. Weak bases. Weak bases. So the following compounds are ionized in H2O. Good, but Mr., how do we know if the given compound is an acid or base, is it strong or weak? What's that question, please? I told you, you should memorize the list of the acids and the bases. Okay? So, أو برسيارة بتزدي يعني منطق نية. تورش مع مكة ولا العصابش مع مدى. بيم قلت من ليستي أسيد كان لبركة بابي من معقولة. يعني باورك لما مكتبي طلبان بي أو اشتعرض لبرنا بي عقوبة دم. بلام إسالي لكو عقوبة دم بس بيمبلي. ديباب نبهرك الرزان نبهرك لبر والله السرسالة دو عادت قرياني ها زين سليدي رق أسيد وبيزا كان دبرنا بي وشي أو كابرا دي باشاي خمي وشي بس دي قناعتك دبي لنا امتحاني هوار بكي أدي أمو كوب زانم كاما والله مكيه باش شبابي من أو زي أقل لخوي دائما يبديني وش باشاي خمي وش باشاي خمي دي بي أوكي ionization باب زين ionization تيا ionization is a process that ions are formed. First of all, is the process of the formation of the ions. Ions are formed, okay, from a solid molecule. Solute molecule, look, molecule. It means we have a molecular substance. What are the molecules? Which molecule here do we need to have? Okay, strong acid, weak acid, weak base. By the action of solvent. Okay, what's the solvent here? H2O. So if I say, which of the following can produce ions, can form ions by the action of H2O? Strong acids, and weak bases. Okay? Look. So this is the process of the formation of ions instead of the separation of the ions. Because in the dissociation, the ions are already present. They just separate. But here, we will get some new things, okay, that, you know, we don't have it, we don't have it previously. We will obtain some new things. That's why we will say formation. Formation is totally different from the separation. Separation, it means we have already we have two things that are going to separate from each other. Okay? Look. Ionization occurs in polar molecular electrolyte compounds. What are the polar molecular electrolyte compounds? As I say, these are polar molecular electrolyte compounds. Let me tell you how to write the ionization reaction. Okay? I'll solve 3 to 4 examples. Okay, HCl as an example of the strong acid. Let me do this again, I'm sorry, because of the following dots. HCl, okay, it's a strong acid. HF, it's a weak acid, and NH3, example of a weak base. So they ionize or they dissociate? They ionize. Be careful. How to write the ionization reaction for the following compounds? If you remember, NaCl, since it's a salt, it's an ionic compound, so it will dissociate. Water must be here, and then we will separate the ions, Na plus and Cl negative, right? But how about this? Is that, do we need to do the same thing? Water, we need to put water above the arrow, or it must be written in somewhere else? Yeah, here, in the ionization reaction, water must be here as one of the reactants. Okay, so we will add water to the substance like one of the reactants. Good. Then, this is a strong acid or weak acid? Strong. For the strong electrolytes, we will use this kind of arrow. This is called direct or forward. Forward. Okay? So we will use this one because this is a strong acid. That's why we have to use this arrow. Then, for the acids, if we have acids, they donate proton. If we have an acid, try to remove H from the acid's molecule to the water molecule. Bring the H from the acid's molecule. Look, look, look. Stay with me. Here we have a proton. Bring that proton to here. Okay, in case of acid, just eliminate H from the acid's molecule and pour it to water. Then, let's write the products. Now, H2O with one H of the acid will become H3. H3O, but by positive sign. The one that increases its number of H must be positive. Plus, what left here? Cl negative. Good? Let's do the same thing here. Ionization water must be here, plus H2O. But mister, this is a weak acid. Do we need to write the direct arrow or something else? We have something else. Yeah. For the weak electrolytes, we'll use this kind of arrow. This is called reversible. Reversible. Not reverse. Reversible, please. Reversible, it means we have both directions together. It will establish the equilibrium state. Look, reversible contains two parts. The one towards the right side is called forward, and this one towards the left side is called reverse. Right? In total, we will say this is a reversible arrow. So we'll write the reversible arrow here. Okay? This is for the strong electrolytes, and for the weak electrolytes, we have a reversible arrow. Then, because this is an acid, again, try to transfer H here to water molecule. So H2O will become what? H3O plus what left? F negative. Good. Is there some special name for this, mister, please? Yeah, of course. This is called hydronium ion. Hydronium ion. Cool. Hydronium ion. That means the dissolution of acids, including strong and weak, results the formation of hydronium ion. In water, of course. Hydronium ion. So how to get the hydronium ion? They try to answer this question. Between them, look, by transferring hydrogen from the acid's molecule into the water molecule. We call this proton transfer. Later we'll get this in chapter 2. Okay? So if we transfer hydrogen of the acid to water molecule, we will get the hydronium ion. Good. How about this one? Okay, this is a weak base. Add H2O. Good, because it's weak. I will write a direct arrow. Agree? No. This is a weak electrolyte, so we should write the reversible arrow. Reversible arrow. This kind of electrolytes, they establish the equilibrium. Be careful. Good. Then, Mister, you said if we have acid, we'll transfer H of the acid to water molecule. Is that the same for the bases? No. Look, for the bases, the process is opposite. Try to write water molecule in the reaction with the bases like this. H, OH. Okay, both are the same. H2O, H2O. In this case, the process is opposite. This time, we will take H from the water molecule to the base. Like this. Mister, if we have acid, the acid molecule will donate the proton. But if we have a base, the base molecule will attract a proton, will accept a proton. The process is opposite. The processes are opposite here. Good. So now, what are the products here? Look. NH3 plus 1H of H2O will become NH4 positive. The one that increases its number of H must be positive. What left here? OH negative plus OH negative. This is hydroxide ion. Hydroxide ion. This is how you write. You can write the ionization reaction like this. Write water as one of the reactants. Then, if it's strong, write the direct arrow. If it's weak, write the reversible arrow for the equilibrium establishment. Then write the products. But, okay, I said the process of the formation of ions that are not present previously. Look at it. Do we have any H3O here previously? No. This is called formation of a new species here. How about this? Is there any H3O here? No. This is called formation, obtaining a new thingus from nothing. Look, here, is there any OH here? Look, no. So this is a new ion. This process is called formation of the ions. But here, this is a dissociation reaction. That's why I will say separation of the ions, because the ions are already present, we just separate them. Look, we have the same species as the reactants, so they just separate. Okay? These are the differences between the ionization and the dissociation. Ionization is for the molecular electrolytes. Dissociation is for the ionic electrolytes. Here we'll get the new ions, but here the ions are already present, they just separate from each other. Okay, good, nice. Okay, let me write another equation. I love this really. Look, this is methylamine, one of the weak bases. This is ionize or dissociate, of course. Since it's a weak base, so it must ionize. Plus H2O, it's a weak base. We should write the reversible arrow. Okay, for the base, we will take what? We will take hydrogen from the molecule of water. With the weak bases, try to write water like this. Okay? Look at it. Hey, let me change the color, please. Okay. Bring this to where? Okay, to the nitrogen atom here. So the product is CH3, NH2 plus 1H of this, NH3 positive. What left here? Only OH. Good? So try to solve this. This is your homework. Look. C6H5 NH2 plus H2O. Try to complete this reaction. Okay? Do it. Check yourself. I think I have explained all of them in better detail. And now, the extent to which solid ionizes in solution depends on. Okay? Or, how do we know if the given compound ionizes or not? Look, we have two forces. Example, this is a molecule of HCl. Okay? After its dissolution in water, think about this as a glass of water. Okay? We have HCl okay, among the molecules of H2O. Now, there are two different forces that they compete each other. The first force, it's the covalent bond. Look, the strength of the bond within the molecule, also called covalent bond. Covalent bond, also called covalent bond, okay? The strength of molecule, the strength of the bond within the molecule, also called covalent bond. And the next one, the strength of the attraction between the solid and solvent, also called water attraction force. Water attraction force. So we have the following two forces that they compete each other. Look at this. The first one and the second one. I don't like to read their names always, so I will mention, instead of saying the strength within the bond of the molecule, I'll say the first point. And instead of saying water attraction force, I'll say the second point, okay? So this is just for time saving. Look at it. The first point is inversely proportional with the ionization, with the degree of ionization. As much as the first point gets stronger, the ionization is decreased. Be careful. لبرك بابي بس أدو point لبرك باشا بالتجنسي. تاوكو strength equivalent bond increase به ionization must be decreased because you know أگر أو bond بقوة be strong. If this bond gets stronger, it will become very hard to be broken, okay, to release to form the ions. Okay, think about this. This is an acid, right? If this bond is strong, then removing hydrogen here will become something impossible. We cannot remove hydrogen into water molecule to form H3O. But if it's weak, we can easily remove this. Okay? Imagine? Good. The second one, the strength of attraction between solid and solvent, which is water attraction force. This point is directly proportional with the degree of ionization. With degree of ionization. So now, if the second point is greater than the first point, ionization occurs. Okay, but if the first point is greater than the second point, ionization does not occur. Be careful with this. Okay, it means if the attraction of water is overcome the covalent bond, such a compound must be ionized. But if water attraction cannot overcome the covalent bond, this compound must stay the same without being ionized. Okay? So anytime if I say, why this compound HX ionizes in water? It ionizes, okay. Since it ionizes in water, that means water attraction can overcome this bond. It means the second point is stronger than the first point, okay? And vice versa. For sugar molecule, C6H12O6, it cannot ionize. Okay, there's no ionization for the dissolution of glucose in water because water cannot overcome the covalent bonds, the attraction within the bonds, within the molecule, okay? Good? So I think I have explained the whole points here. Try to make your revision. Inshallah مزبوط دبي لبو درسي دابي أو برسيارانا لبو عزيزي خوم شرح لكم إن شاء الله لقلم بعاقل بخوينا, okay? So see you in the next lesson.